Good morning dear students, welcome back. I am Dr. Nagaraj explaining model question paper VTU Engineering Physics for Computer Science and Engineering and Allied Branches. This is paper number 2. I have already uploaded first paper in detail. I have discussed, and also I uploaded second paper module 1. This is about module 2, that is modern physics and quantum mechanics. Dear students, here comes the question number 3a. Set up one-dimensional time-independent Schrodinger wave equation. So we have to derive the equation for matter wave which is traveling along one direction, one dimension or one direction. It goes like this. First of all, dear students, whenever a wave is propagating along x-axis, it is given by one differential equation, that is d square y by dx square is equal to 1 by v square into d square y by dt square. You need not have to derive this equation, straight away you can write. So we know that anta shuru ಮಾಡಿ, where v is equal to velocity, it is given by omega by k. Omega is nothing but 2 pi nu and k is nothing but 2 pi by lambda. So omega is nothing but 2 pi f athwa nu and k is nothing but 2 pi by lambda. This is fundamental. Now similarly, for matter waves we can write, for matter waves, you know, matter waves are the waves associated with particle in motion. In matter waves there is a variable called wave function. It is a function of x and t. Actually it is a function of x, y, z. 3 dimension adre, one dimension ಆಗಿರೋದ್ರಿಂದ I take only x, that is position coordinate, and t always time coordinate. So we can write this equation as d square psi by dx square is equal to 1 by v square into d square psi by dt square. Call this as equation 1. So we have to eliminate this dt, the second parameter. In the RHS, this parameter we have to eliminate, then only it becomes time independent. Okay, see here wave function is a solution. Wave function we can show that is equal to e to the power of I into kx minus omega t. Call this as equation 2. Directly you can write the solution. So even in solution derivation also, we need not have to show all the detailed derivation steps. Straight away you can write the solution. Okay, now differentiate the equation number 2 with respect to t, that is d psi by dt is equal to a into e to the power of I kx minus omega t into I omega. Remember, I am differentiating with respect to t, therefore it is minus I omega. Okay, next it is double differentiation, that is d square psi by dt square is equal to a into e to the power of kx minus omega t into once again minus I omega, so it will be minus I omega square. Okay, so therefore this becomes d square psi by dt square is equal to, dear students, look at this is nothing but psi. Okay, that is equation number 2, into minus square means plus. I square is nothing but root of minus 1 whole square, it is nothing but minus only, into omega square. I hope you followed this step. Call this as equation number 3. ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ, ಮೈನಸ್ ಸ್ಕ್ವೇರ್ ಅಂದ್ರೆ ಪ್ಲಸ್ ಆಗುತ್ತೆ, ಐ ಸ್ಕ್ವೇರ್ ಬಂದ್ಬಿಟ್ಟು ಐ is actually root of minus 1 ಅಲ್ವಾ, ಐ ಸ್ಕ್ವೇರ್ ಆದಾಗ ಏನಾಗುತ್ತೆ, ಇದು root of minus 1 whole square becomes root of minus 1, sorry, ಬರೀ minus 1 ಆಗುತ್ತೆ. So I square is therefore equal to minus 1. Well, let us now substitute equation 3 in equation 2. We get equation, substitute ಇವೆಲ್ಲ ಬರಿಬೇಕು ನೀವು, substitute equation 3 in equation 2 ಅಲ್ಲ, ಸಾರಿ, equation 1 ನಲ್ಲಿ substitute ಮಾಡಿ. So we get, I continue here, right? So equation 1 becomes d square psi by dx square is equal to 1 by v is nothing but omega by k whole square into d square psi by dt square is nothing but minus omega square psi. Please follow carefully. Equation 1 ನಲ್ಲಿ, equation 1 ಅನ್ನು ಒಂದ್ಸತಿ ಗಮನಿಸಿ. This is equation 1. In this equation 1, this second term I am replacing by minus omega square psi by psi, that's all. Okay, continue further. This becomes d square psi by dx square is equal to See, omega square cancel, k goes to numerator, so it becomes minus k square psi. Okay, and you know what is k value? K is already there, it is 2 pi by lambda, therefore this becomes minus 4 pi square psi divided by lambda square. So d square psi by dx square is equal to minus 4 pi square psi divided by lambda square. Call it as equation number 4. Okay, next see, the de Broglie wavelength is given by h divided by square root of 2me. E stands for kinetic energy, I write it as Ek. Okay, so therefore lambda square is equal to h square divided by 2m Ek. So square root will go off. Okay, so I continue the remaining here. Actually lambda square is equal to h square divided by 2m. In place of Ek, I write total energy minus potential energy. Sorry, U, I will use V instead of U. I will use V for potential energy. See, total energy is nothing but kinetic energy. Total energy bandhubiಟ್ಟು kinetic energy plus potential energy. This is a well known fact. So kinetic energy is therefore total energy minus potential energy. Okay, well, let me continue further. I just erase this part. So I have lambda square with me. Substitute lambda square. Okay, if you want you can call this as equation number 5. What is the equation number 3 is here, 4 is here. Okay, equation number 5. Follow carefully. Substitute equation 5 in equation 4. Okay, equation 4. This is the equation. It becomes d square psi by dx square equals minus 4 pi square psi whole thing divided by, in the place of lambda square, h square divided by 2m into E minus V. Remember, E is not kinetic energy, it is total energy. So d square psi by dx square is equal to minus 8 pi square m. See, this 2m goes to numerator into E minus V also goes to numerator into psi divided by h square. Please follow carefully. Therefore d square psi by dx square plus I take it to the LHS 8 pi square m by h square into E minus V into psi equals 0. So this is the one dimensional equation. One dimensional because I have only dx square here. Time independent because there is no t parameter in this formula. So this is the one dimensional Schrodinger wave equation, and here psi is variable. Okay, well, with this I move on to the next question. Next question is state and explain Heisenberg uncertainty principle. Heisenberg uncertainty principle is one of the fundamental principle, and also you have to talk about principle of complementarity. Here comes the statement. In the simultaneous measurement of both position and momentum of the particle, always there is some error. The product of error in the position and momentum is greater than or equal to h by 4 pi. This is a very well expected question and well known principle. In fact, this is one of the fundamental principle of quantum mechanics. So, application of uncertainty principle, non-existence of electron inside the nucleus anta. Okay, so very important. Okay, in the form of equation I can write delta x delta p greater than or equal to h by 4 pi, where delta x, see one thing dear students, whenever you write the equation, better you explain the terms in the formula. What is delta x, what is delta p, what is h, 4 pi ಅವೆಲ್ಲ ಹೇಳೋದು ಬೇಡ, ಬಟ್ ಇವನ್ನೆಲ್ಲ ಹೇಳಲೇಬೇಕು. ಡೆಲ್ಟಾ ಎಕ್ಸ್ ಈಸ್ ಎರರ್ ಇನ್ ದ ಪೊಸಿಷನ್ ಮೆಷರ್ಮೆಂಟ್, ಡೆಲ್ಟಾ ಪಿ ಈಸ್ ಎರರ್ ಇನ್ ದ ಮೊಮೆಂಟಮ್ ಮೆಷರ್ಮೆಂಟ್, ಲೈಕ್ ದಟ್. ಹೆಚ್ ಈಸ್ ಪ್ಲಾಂಕ್ಸ್ ಕಾನ್ಸ್ಟೆಂಟ್, ಡೆಲ್ಟಾ ಇ ಈಸ್ ಎರರ್ ಇನ್ ದ ಎನರ್ಜಿ, ಡೆಲ್ಟಾ ಟಿ ಈಸ್ ದ ಟೈಮ್ ಇಂಟರ್ವಲ್ ಎರರ್ ಅಂತ ಮೆನ್ಷನ್ ಮಾಡಿ. ದಿಸ್ ಈಸ್ ಹೈಸನ್ಬರ್ಗ್ ಅನ್ಸರ್ಟೆಂಟಿ ಪ್ರಿನ್ಸಿಪಲ್. Principle of complementarity was first proposed by Bohr. Bohr ಏನು ಹೇಳ್ತಾನೆ ಅಂತಂದ್ರೆ, ಅಕಾರ್ಡಿಂಗ್ ಟು ಬೋರ್ ಪ್ರಿನ್ಸಿಪಲ್, ಎ single quantum can exhibit any single quantum state, ಅದು ಪಾರ್ಟಿಕಲ್ ಇರ್ಬೋದು, ಆಟಮ್ ಇರ್ಬೋದು, ಮಾಲಿಕ್ಯೂಲ್ ಇರ್ಬೋದು, ಆಯ್ತಾ, ಎನಿ single quantum state can exhibit either particle nature or wave-like nature. So it will exhibit a particle nature and wave-like nature together, but at a time it will be either showing only particle nature or wave nature. Okay, so I repeat, Bohr's complementarity principle states that a single quantum can exhibit a particle-like or wave-like behavior, but never both at the same time. See, for example, photon. Photon at the time of emission it behaves like a particle, at the time of absorption it behaves like a particle, during the propagation it won't behave like a particle, it behaves like a wave. So overall photon can be having both particle and wave nature, but at a time it will be either particle or at a time it will be either particle or wave. For example, all-rounder in cricket, all-rounder. Okay, Kapil Dev is all-rounder, Sachin Tendulkar is all-rounder. Okay, you can name some cricketers who are all-rounders, but at a time they can do only one role. Either they can bowl or they can bat, but they cannot do both at a time. Okay, so this is the single behavior nature. Okay, let me proceed. Now if you try to measure only particle nature, you get more important information, more accurate information about the particle nature, but at the same time you lose information about the wave nature. Conversely, if you concentrate only on the wave nature, then you lose information on the particle behavior of that quantum state. Okay, so when importance is given to the particle nature, its wave nature is suppressed, means neglected, vice versa. This inability, it is impossible to measure both of them simultaneously. ಬರೀ ಪಾರ್ಟಿಕಲ್ ಅಷ್ಟೇ ಮೆಷರ್ ಮಾಡಬಹುದು, ವೇವ್ ನೇಚರ್ ಅನ್ನ ಆಗೋದಿಲ್ಲ. ಬರೀ ವೇವ್ ನೇಚರ್ ಅನ್ನ ಮೆಷರ್ ಮಾಡಬಹುದು, ಪಾರ್ಟಿಕಲ್ ನೇಚರ್ ಆಗೋದಿಲ್ಲ. ಎರಡನ್ನೂ ಟ್ರೈ ಮಾಡಕ್ಕೆ ಹೋದಾಗ ಆಲ್ವೇಸ್ ದೇರ್ ವಿಲ್ ಬಿ ಸಮ್ ಎರರ್. ದಿಸ್ ಈಸ್ known as principle of complementarity. This principle of complementarity leads to uncertainty principle. So principle of complementarity ನಲ್ಲಿ ಏನು ಹೇಳ್ತಾನೆ, it is impossible to measure both particle and wave nature simultaneously ಅಷ್ಟೇನೆ. Whereas in uncertainty principle what he says, there will be some error. If you try to measure, it is impossible to measure accurately, but if you try to measure, there will be some error. That product of the error is greater than or equal to h by 4 pi ಅಂತ ಹೈಸನ್ಬರ್ಗ್ ಹೇಳ್ತಾನೆ. ಅರ್ಥ ಆಯ್ತಲ್ವಾ? ಅನ್ಸರ್ಟನಿಟಿ ಪ್ರಿನ್ಸಿಪಲ್ಗೂ ಕಾಂಪ್ಲಿಮೆಂಟಾರಿಟಿಗೂ ಕನೆಕ್ಷನ್ ಇದೆ. ಕಾಂಪ್ಲಿಮೆಂಟಾರಿಟಿ ಪ್ರಿನ್ಸಿಪಲ್ ಕೇಮ್ ಫಸ್ಟ್, ನೆಕ್ಸ್ಟ್ ಕಂಟಿನ್ಯೂಯೇಷನ್ ಈಸ್ ಅನ್ಸರ್ಟನಿಟಿ ಪ್ರಿನ್ಸಿಪಲ್. ಕಾಂಪ್ಲಿಮೆಂಟಾರಿಟಿ ಪ್ರಿನ್ಸಿಪಲ್ ಅಲ್ಲಿ ಏನು ಹೇಳ್ತಾನೆ, ಪಾರ್ಟಿಕಲ್ ನೇಚರ್ ಅಷ್ಟೇ ಗಮನ ಕೊಟ್ಟರೆ ವೇವ್ ನೇಚರ್ ಸಪ್ರೆಸ್ ಆಗುತ್ತೆ, ವೇವ್ ನೇಚರ್ ಅಷ್ಟೇ ಗಮನ ಕೊಟ್ಟರೆ ಪಾರ್ಟಿಕಲ್ ನೇಚರ್ ಸಪ್ರೆಸ್ ಆಗುತ್ತೆ. ಎರಡನ್ನೂ ನೀವು ಅಟ್ ಎ ಟೈಮ್ ಮೆಷರ್ ಮಾಡೋಕ್ಕೆ ಕಷ್ಟ ಅಂತ. ಸೊ ಅದನ್ನೇ ಕಂಟಿನ್ಯೂ ಮಾಡಿದರೆ ಆಲ್ವೇಸ್ ದೇರ್ ವಿಲ್ ಬಿ ಸಮ್ ಎರರ್. ಪ್ರಾಡಕ್ಟ್ ಆಫ್ ದ ಎರರ್ ಈಸ್ ಗ್ರೇಟರ್ ದನ್ ಆರ್ ಈಕ್ವಲ್ ಟು h by 4 pi ಅಂತ ಹೈಸನ್ಬರ್ಗ್ ಹೇಳ್ತಾನೆ. ಇದು ಪ್ರಿನ್ಸಿಪಲ್ ಆಫ್ ಕಾಂಪ್ಲಿಮೆಂಟಾರಿಟಿಗೂ ಅನ್ಸರ್ಟನಿಟಿ ಪ್ರಿನ್ಸಿಪಲ್ ಇರೋ ಸಣ್ಣ ಡಿಫರೆನ್ಸ್. ದಟ್ಸ್ ಆಲ್. Okay, this is most important principle because for quantum mechanics uncertainty principle is taken as one of the fundamental principle. That's why it is most important principle. Now comes the numerical problem. The problem goes like this: an electron having kinetic energy 50 electron volt is in vacuum. Calculate the group velocity assuming that mass of the electron is equal to rest mass. ಸೊ ಇಲ್ಲಿ ಗ್ರೂಪ್ ವೆಲಾಸಿಟಿಯನ್ನು ಕೇಳಿದ್ದಾರೆ ನೋಡಿ. ಒಂದು ಮ್ಯಾಟರ್ ವೇವ್ ಹೋಗಬೇಕಾದ್ರೆ ಒಂದು ಗ್ರೂಪ್ ಫಾರ್ಮ್ ಆಗುತ್ತೆ. ಓಕೆ, ದೇರ್ ವಿಲ್ ಬಿ ಎ ಫಾರ್ಮೇಷನ್ ಆಫ್ ದಿ ಗ್ರೂಪ್. ದಿಸ್ ಗ್ರೂಪ್ ವಿಲ್ ಟ್ರಾವೆಲ್ ವಿತ್ ವೆಲಾಸಿಟಿ ಕಾಲ್ಡ್ ಗ್ರೂಪ್ ವೆಲಾಸಿಟಿ ಅಂಡ್ ವಿ ಕ್ಯಾನ್ ಶೋ ದಟ್ ಗ್ರೂಪ್ ವೆಲಾಸಿಟಿ ಈಸ್ ಈಕ್ವಲ್ ಟು ವೆಲಾಸಿಟಿ ಆಫ್ ದ ಪಾರ್ಟಿಕಲ್ ಇಟ್ ಸೆಲ್ಫ್. ನೌ ವಿ ಹ್ಯಾವ್ ಟು ಫೈಂಡ್ ಔಟ್ ದಿ ವೆಲಾಸಿಟಿ ಆಫ್ ದ ಪಾರ್ಟಿಕಲ್. ಓಕೆ, ನೌ first you consider lambda, that is equal to h by square root of 2me suffix k, where ek stands for kinetic energy. Substitute, that is 6.62 into 10 to the power of minus 34 divided by square root of 2 into mass of the electron is 9.1 into 10 power minus 31. Kinetic energy is 50. Electron volt shall be converted into joule. Okay, so simplify this. Just 1 minute, I will do it for you. 2 into 9.1 to the power of minus 31 into 50 to the power of minus 19 into 1.6. For that square root and then reciprocal of this. This multiplied by Planck's constant 6.62 to the power of minus 34. This gives you 1.735. Answer, lambda is 1.735 into 10 to the power of minus 10 meter. This is lambda. Next, this is first one. Next, actually we want velocity, group velocity. Dear students, you know lambda is equal to h by mv. implies V is equal to h divided by m into lambda. This V itself is particle velocity. Okay, so V is equal to 6.62 into 10 power minus 34 divided by mass is 9.1 into 10 power minus 31 into 1.735 into 10 power minus 10. So solve this to get the answer. So I do it 9.1 to the power minus 31, reciprocal of this multiplied by 6.62 to the power of minus 34 comes out to be 4.193 into 10 to the power of 6 meter per second. This is the particle velocity. I hope you follow this numerical. Actually de Broglie wavelength anna kelidaralla, calculate group velocity and de Broglie wavelength eradannu kelidare. Kelide hodru kuda ನಾವು we have to calculate de Broglie wavelength. Okay, now comes the question number 4a. This question I have already discussed in model paper 1, that is particle moving in a potential well of width a and obtain the eigenfunction and energy states. I just run through the content. Please follow my explanation which I have already given in my previous video. Here is a particle trapped in the one dimensional potential well. If I am correct, this is most expected question. Idra ಬಗ್ಗೆ boundary conditions ella helidini. Look at this. These are the boundary conditions. There are two cases, case 1, case 2. Okay, case 2 is more important than case 1. In case 1, we take particle to be outside, we consider case outside. Case 2, we consider inside. Outside there is no particle, potential is infinity. Inside particle is there, potential is 0 anta tagondu explain madidini nanu. All these steps will come. Just pause the video, note down the steps. This is the eigenvalue, energy correspond to ground state, and then normalization condition we apply it to this wave function. This is eigenfunction, and we continue with the integration. Just I run through the steps, you pause the video, right, and go through these steps and practice. You will get this equation, detailed explanation why it has to be integrated from here to here, how actually it is 1 minus cos 2 theta ivella helidine nanu. Sumne just to save time, just to avoid the repetition, I am running through the slide. Well, with this I move on to the next question, that is question number 4b. Explain the physical significance of wave function. Wave function in a significance eno. First one, wave function andre definition kotbidi first. Wave function is a mathematical function of quantum mechanics which is determined by physical situation of the system and is represented by psi. One system antandre illi particle bandbiಟ್ಟು it can be a charged particle or a neutral particle. It can be a lighter particle or a heavier particle. Andre elementary particle irbodu, electron, proton, neutron, atom, molecule, group of atoms ಎಲ್ಲದಕ್ಕೂ apply ಆಗುತ್ತೆ. Whether particle is at rest or in motion, that we can explain with the help of wave function, and that wave function is given by this equation which I already wrote earlier. I just write it once again. So wave function is given by psi is equal to, right, a into e to the power of I into k x minus omega t, where k is wave number, that is 2 pi by lambda, omega is equal to angular frequency, that is 2 pi nu, and a is of course constant. Okay, so let me read the importance of wave function. The wave function psi contain all possible information about the system. Illi system antandre ಒಂದು particle anta. All information about the particle andre enu, what is the charge on the particle, what is its velocity, kinetic energy, momentum, potential energy, spin, and other details like with what energy it is hitting or colliding, or how much energy it has to possess to come out of the potential well, or whether probability of finding the particle is maximum or minimum at a given instant of time. All these information, that means position measurement, all these things we can estimate, we can extract from the wave function. So that wave function is going to tell you about the status of the particle. That's why it is called as a state function. Once the wave function is known for a particular system, the physical observable quantities like energy, momentum, position, etc. can be determined. ಇದನ್ನೇ ನಾನು ಹೇಳಿದ್ದು. But wave function is also called as, wave function is a measure of probability of finding the particle. Like you are in your college from morning 10 to evening 5. What is the probability of finding you in your college morning 10 to 5 ಅಂತ ಕೇಳಿದ್ರೆ probability of finding is 100% ಅಂತ. What is the probability after 5 o'clock in your college? 0%. ಈ ತರ probability of finding the particle at a given place at a given instant of time can be measured with the help of a wave function. And this wave probability cannot be negative, cannot be imaginary. To overcome this problem, wave function cannot be imaginary, cannot be negative. So therefore, to overcome this problem, Max Born gave a suggestion. What suggestion? Don't change psi value, let it be imaginary only, yearly, let it be negative only, but better you take modulus of psi square. Psi square is nothing but psi multiplied by its complex conjugate. When wave function is multiplied, when a complex number is multiplied by its complex conjugate, it converts into real number. And once you take psi square, it becomes real and positive. See, this psi square is something like, I tell you what actually this psi square is. See, in a wave, this is a wave, okay. This is amplitude, it is positive. This is amplitude, it is negative. Amplitude can be negative. Suppose if I take amplitude square, whether it is minus a square or plus a square, in both the cases it is a square only. This is nothing but intensity. Intensity is also called as radiation density. Similarly, see, by taking square, I avoid this negative sign. Like that, to avoid imaginary, I multiply wave function by complex conjugate and then I take modulus. That is modulus of psi square. This is actually psi square. This modulus of psi square modulus ee tara irbeku. Okay, this is nothing but probability density. This is what Max Born interpreted. So this is about wave function. So wave function andre, it tells you about the status of the particle, it tells you about the position of the particle, it helps you to find out all the details of the particle, and better you take probability density rather than probability. Okay, so this is about wave function. And any wave function satisfying all the properties can be called as eigenfunction. And by using this eigenfunction, if you find any value like energy value, momentum value, etc., then that value is called as eigenvalue. This I think I mentioned in my previous video. Now comes the numerical problem. Speed of an electron is measured within an uncertainty of 2 into 10 power 4. That means delta V is equal to 2 into 10 to the power of 4 meter per second in one dimension. What is the minimum width, that is delta x question mark? Dear student, this is certainly on uncertainty principle, that is delta p delta x greater than or equal to h by 4 pi. You know p is equal to m into v, therefore delta p is equal to m into delta v. Therefore m delta v delta x greater than or equal to h by 4 pi. I want just delta x, that is greater than or equal to h by 4 pi m into delta v, that is equal to 6.62 into 10 power minus 34.62. Dear students, please do substitution. Simply doing calculation in your calculator and writing the final answer will not fetch you the full marks. Always you have to show the detailed calculations including substitution. Now you substituted, do the simplification. 4 into 3.14 into 9.1 to the power of minus 31 into 2 to the power of 4. This is my numerator. So then I take the reciprocal of this, multiply by 6.625 or 6.62 to the power of minus 34. I get 2.898. So delta x comes out 2.898 into 10 to the power of minus 9 meter or 2.898 nanometer. This is delta x value. I hope you are following. So with this I stop this particular paper discussion, module 2. I will come back to you with module 3, module 4, module 5. I think in my next video I will upload the solved paper and the answer with answer I will upload. I will give you the link, you can download and you can refer to it. I hope you all are enjoying my videos. Please keep supporting me. Okay, thank you very much.